Welcome to those joining. We'll get started in just a moment. Okay, well, welcome people to the ibpsa-usa webinar. This is hosted by the ibpsa-usa Education Committee. My name is Eric Calderup. I'm chair of the ibpsa-usa Education Committee. So today's webinar is updates in ASHRAE Standard 209, 2024, the building performance simulation process. And we have 4 speakers today. All of these speakers are members of the committee, the ASHRAE committee that is responsible for developing and maintaining that standard. With Christina LaPearl, myself, Eric Calderup, Patrick Pease, and Chris Schaffner. Drew Crawley, who can't make it today, was also helped develop this presentation. So just a couple notes. This webinar is being recorded, so it will be posted in a while or coming up on ibpsa-usa's YouTube channel, where you can also check out previously recorded ibpsa-usa webinars. And in addition, the slides will be available. You'll be able to find those on the ibpsa-usa website at some point in the not too distant future. If you are an AIA member, you can receive continuing education units. Those will be submitted in a week or so. If you did not submit your number when you registered, please check in with admin@ibpsa.us to get that set up squared away. And then briefly our agenda. So we'll talk real quickly about energy modeling and the design process to set the context, and then go into the standard. So what is ASHRAE Standard 209? Probably a number of you are already familiar, but you'll get a quick orientation there. And then one of the focuses today is what's new in the 2024 version. And we'll try to have some Q&A time at the end. Please, as we go along, feel free to enter any questions or comments in the Q&A section, and we'll try to make sure we get to those. I guess panelists, anything else before we dive in here?
Sounds good, Eric.
Let's do it.
Okay, now I will hand off to Chris Schaffner.
Yeah, hi. So thanks everyone for joining today. Hopefully all of you have some familiarity with ibpsa and the ASHRAE Standard 209, but just kind of as a recap of why 209 was originally developed. It was developed originally back about 10 or 11 years ago. The folks who were on the first 209 committee started working on it. And it reflects the changes in the energy modeling world over the last 20 or so years. Back a long time ago, when we ran models, they were research, they were expensive, they ran on big mainframe computers. And so it was a pretty rare thing to be running any kind of energy simulation. Starting with the mid-1980s, we started to see the prevalence of performance-based codes like ASHRAE 90.1 and the IECC. And along with that, a growth of utility incentive programs. And at the same time, computing power increased, and the typical consulting engineer probably for the first time had access to some computers. I know when I started right out of college in 1988, in my office of 60 engineers, we had about 3 computers in the whole place. And it was a pretty rare thing to be able to even get access to the computers. So the computing was not ubiquitous, but it's changed a lot over the last 30 or so years, so that now we have incredible amounts of computing power at our fingertips, in our phone, in our appliances everywhere. At the same time as the performance-based codes, we also started to see the growth of the global green building movement, which was especially reflected with the growth of LEED. And one of the things that LEED did was to give a lot of points if you ran energy simulation and showed performance improvements over a model code like ASHRAE 90.1. And then in fact, in LEED version 2.2 in 2007, they made it a requirement that you get at least 2 points in that energy credit, which meant that pretty much every LEED project had to run a model. And so along with that, ASHRAE developed the standard, and it was first published in 2018, and we've just published the updated version of 2024. Eric. I think there's more on this slide. Click ahead. Yeah, and along the way, ibpsa was formed, and a big difference, big change was ASHRAE 9.1 Appendix G. So we were able to use modeling for the first time to show beyond code performance. And that was really developed around standards like LEED in mind. And that's led to the growth of the energy simulation community. And so we're in a situation now where a lot of people are running models, but when we run the models, we're not necessarily getting all the value that we want out of them. We often are starting our models, Eric, on the next slide, pretty late in the process. We are really running validation models. So we're modeling far in advance or very far down the line, basically designing the building and then running a model to see how we did, versus using a model as a design tool. So the original impetus of creating 209 was to give people some guidance as to the way to use energy simulation and building simulation as part of an integrative design process. Where are all the different places we use modeling and how might we use that? And so that was we're one of the drivers for this. And so, again, what we see is that if we can do early modeling, we can do that and have a big benefit at a small cost, right? We can run simple models, we can run block models, we can run partial models, and we can have big impacts on things like the building form and orientation, the system selection, the building envelope. If we're waiting to the end of design to then run a model, it's very hard for us to go back. At the same time, those models are very complex. So we want to make sure that we have a way to use modeling throughout the life cycle of the project and use it in an appropriate way. And that's really what 209 is about. And so, that was the driver for the standard. So much of the modeling driven by Appendix G was modeling at the end of the design for compliance. And so we wanted to use 209 to highlight this integrative process. And we expected that it would be adopted by organizations that certify high performance buildings like USGBC and LEED, and also potentially by utilities and other agencies that provide incentives for low energy buildings. And also can serve as a roadmap for an owner who's putting out an RFP for modeling services or an architect, so that we are talking in the same language. And so that, if one firm is submitting on a model, another firm submitting on the model, we can compare their scope based on the requirements of ASHRAE 209 and understand what the different offerings might have in play. So that's kind of the motivation behind the standard. And now we have ASHRAE Standard 209 2024. And one of the things you'll see that's a change is that we've changed the title, purpose, and scope. So now it is not just energy performance simulation, it is building performance simulation. But our purpose is to establish the minimum requirements for the process of using simulation to evaluate building performance and inform decision making. And as I mentioned before, the idea is that it would be adopted by organizations certifying high performance buildings or utilities around incentives, and especially building owners and as well modelers when we're writing a scope, putting together a proposal, things like that. So we're going to talk mostly about all the things that are new in the 2024 edition. And as I mentioned, there's a new title, purpose, and scope, building performance simulation. We've updated the language around who is qualified to be a modeler. We've revised a lot of terminology, updated the general requirements. We'll see the general requirements look at the minimum requirements if this was to be adopted by an AHJ. And in addition, we've made some changes, some minor, some major, to modeling cycles. And we've also added some really great, I think, informative appendices. And some of these appendices are kind of worth the price of the standard by itself, I think, because of all the additional information that's in there. And as part of this, ASHRAE 209 is now under continuous maintenance, just like many other standards you're familiar with, which means that we continue to work to update. And so if you've got ideas, we would love to hear them. That 209 committee would love to hear what's working, what's not. Where does the industry, where does the community of modelers need more guidance? Where would these sorts of standards help with your process? So the basic structure of 209 looks a lot like other ASHRAE standards. There's the purpose and scope. There's a section of definitions. And then section 5 are the general requirements. This includes the kind of software you might use, who the modeler could be, the climate analysis, benchmarking, setting performance goals. We'll talk about that in a little more detail. And then we've got in section 6, 7 different design phase modeling cycles. And the idea here is that projects don't necessarily do all of these. In fact, projects would never do all of these. They're going to pick and choose which ones are appropriate. And then similarly, an additional 4 cycles after during construction or during occupancy. And for each one of these cycles, the standard outlines the requirements within that cycle. So I think we've got a next slide that shows that. No, we don't. So if you're complying with 209, there are some basic requirements. You're going to have to establish an energy performance goal for the project. You're going to have to conduct an energy-focused design charrette. You're required to do climate and site analysis. You need to have a qualified modeler. And in addition, the minimum requirement would be that you are going to perform an energy model before the end of the schematic design, focus on reducing the peak loads, which is modeling cycle 3. And then you've got to pick one other design phase modeling cycle and do that as well. So in the circumstances where an AHJ is requiring 209 certification or 209 compliance, these are all the things you would need to do with that. So talk briefly about one of the updates that was seen as a barrier for 209. We've updated the modeler qualifications. It used to just say be a BEMP or a BESA. And we've expanded a little bit to say, first of all, a modeler is the person who's running the model, but it's possible that actually the person supervising that modeling work would be the qualified modeler. So it could be either the modeler directly or the supervisor of that, recognizing that that's the way a lot of larger firms work. But this modeler or the individual supervising the work of the modeler should have completed at least 5 energy modeling projects and have one of the following 4 qualifications, either be a BEMP, BSA, or a design professional, so a PE or a licensed architect with 2 years of building energy modeling experience, or absent that, 3 years of building energy modeling experience. And then, as with everything in standards, the AHJ can set other qualifications along the way on that. So that's hopefully has removed some of the barriers for using 209 with that change. And I think at this point, I'm going to hand over to Patrick, who's going to talk a little bit more about the rest of the compliance piece.
Actually, Chris, you're handing over to me.
To Christina, I am. Yes, sorry about that.
All good, all good. All right, so Chris already touched on this, on what's required to comply with the standard, but this slide I think shows it quite nicely. All projects are required to comply with sections 5.3 through 5.7. And I'll describe what these are in a little bit more detail on subsequent slides. So not only are they required to comply with 5.3 through 5.7, but all projects are also required to conduct modeling cycle number 3, which is load reduction modeling. And Patrick will tell you a bit more about what's involved in this cycle later on. Now, what's up to the project team is which additional modeling cycle that they'd like to complete. And the thing to note here is that this one additional cycle that needs to be completed in order to minimally comply with the standard needs to be during the design phase. So we have modeling cycles during the construction and then post-construction phases. The requirement is that at least one additional cycle, in addition to number 3, needs to be conducted during the design phase. All right, next slide, please. So let's talk a little bit more about these required sections. 5.3, which is climate and site analysis. That is the first of the required activities. And that just involves, taking a look at the site, reviewing local climate data, such as, heating degree days, cooling degree days, humidity levels, solar radiation, precipitation, all sorts of climate data. And then along with that, assessing the site characteristics. So for an example, is the site shaded by other buildings? Are there a lot of trees on the site? Are there topographical features that will cause shading? Do you have an opportunity to berm the building into a hill? Is there a water source on the site that can maybe be used as a heat source or sink? So those are the kind of site characteristics that you'd want to jot down. So next, after jotting down this climate data and the site characteristics, you would create a list of climate and site specific design strategies. And you would bring this list to the charrette to discuss with the design team. Next slide, please. All right, so sections 5.4 and 5.5. Section 5.4 involves benchmarking. And so as a modeler, you would want to consult a benchmarking source. There are some listed on the slide, such as CBEX data, Energy Star Target Finder. I think a lot of us are familiar with these types of sources. In Appendix B in the standard, there's a whole list of different benchmarking sources that you can go to. But the reason for benchmarking is to, compare your proposed building to, or what you want to do actually is you want to look at the typical consumption of buildings that are similar to your proposed building. And this can help you in setting goals. It's also important to think about how your building is going to differ from the buildings that you are comparing it to. Is it going to have more miscellaneous loads? Is the occupancy pattern going to be different than a typical building? These are important in terms of setting your goals. So you bring your climate and site analysis, you bring your benchmarking analysis to the charrette. And so the standard requires that at least one charrette is held that is focused on building performance. And what you want to really discuss at the charrette is the purpose of energy modeling in the project. Not everyone on the design team is going to understand your role. So part of your job at the charrette as a modeler is to educate them. You want to work with the design team to start honing in on your performance metrics and goals. The charrette is a great time. Maybe by the end of the charrette, you'll have these goals, or maybe that'll be a follow-up item to sort of cement the goals. You want to discuss potential energy efficiency measures to help achieve these goals, and results of any previous modeling that has been done maybe on a similar project. That is often your best guide for the benchmarking analysis and for setting goals. If you have a portfolio of similar projects that you've worked on, that provides really valuable data for helping aid in the design of the current building. You want to talk about the criteria for decision making. Are you just going for the lowest cost option? Is there does it need to meet certain financial criteria in order for a particular option to be viable? Are you just going for absolute lowest energy consumption no matter what? We don't care about costs. I know that never happens, but hey, we can dream. Are you going for lowest embodied carbon? You need to talk about like what is the criteria for deciding whether you're going to go with a particular design alternative versus another. And lastly, you need to come up with the project schedule. You want to come up with roles and responsibilities as well. That's very important. And then, as always, after a meeting, you want to have a set of action items to make sure everyone is held accountable for what they signed up to do. All right, next slide, please. All right, so then after the charrette, you'll want to cement the performance goals for the project, and they are required to be documented in the owner project requirements, OPR. And so goals can take many forms. There can be many different types of goals. So for an example, a project goal may be to achieve net zero energy, maybe net zero carbon, You might select a target energy usage index for the project or a thermal energy demand intensity. Maybe the goal is to achieve LEED Platinum. Whatever that goal is, it needs to be documented in the OPR. Often as well, project teams will come up with discipline or system-specific goals. So this might be something like you want to maximize daylighting. So you want all offices to have daylight dimming controls. Well, I know a lot of people are probably thinking, yeah, but those are required by code anyway. Well, maybe if you have a target for achieving daylight dimming controls in certain space types, that can impact the design in that you can make sure those space types have fenestration adjacent to them, right? So that you can take advantage of daylight dimming controls for lighting. So that's just an example. All right, next slide, please. We have a packed presentation today, so I'm flying here. All right, so I just want to talk about some impactful changes to these sections from 2018 to 2004. So number one, pretty basic, we're just referencing new appendices, and one in particular, the predictive analysis, which will be discussed later in this webinar. Number two, I think, is very important. So changes were made to the language to increase the flexibility regarding the requirements for conducting financial analysis and setting goals. So there's some strike through and underline shown on the slide to give you an example. So if we look at 5.5 on the slide, it used to say that all projects had to establish financial criteria for analysis and decision making. So this was opened up a little so that projects now can establish financial and or other criteria for analysis and decision making, because there are all sorts of energy modeling use cases, and requiring everyone to do a detailed financial analysis, that might not be appropriate for every single modeling use case. So this has been opened up so that there's wider applicability and people aren't being forced to do things that really are not adding value to their particular modeling use case. All right, some informative notes and language changes were made to improve clarity and to help modelers comply with the standard. There's an example on the slide on the right. In 564 now provides an informative note with a list of different performance goals that a project might consider. So these helpful notes have been added throughout the standard. And lastly, these sections were modified to require that someone, it doesn't have to be the modeler, but a member of the team, bring a list of energy efficiency measures to the charrette to make it more productive. And that sort of, I think, helps clarify the purpose of the charrette. Like, you really want to talk about the climate, you want to talk about benchmarking, you want to talk about your performance goals, and then you want to say, okay, what kind of things can we do to get to these goals? And so now you have to bring an EEM list to the charrette. Next slide, please. Okay, so section 5.7 I haven't covered yet. This includes the general modeling cycle requirements for each modeling cycle. And for each modeling cycle, section 7 requires you to check in with your goals, make sure they haven't changed, from when you established them early on. Same with the baseline. Make sure, am I using the appropriate baseline at this point in the project? No matter which modeling cycle you're doing, you want to start thinking about these two things, just to make sure that you are synced up with all the other changes that have been made as the design has progressed. The next requirement, you need to gather specific input data for your model. And the third, this section requires quality assurance be performed on this input data. So we want to make sure that it's not garbage in. We want to make sure that the modeler is inputting solid data that aligns with, the current design or whatever it is you're analyzing. So there are requirements for QA, QC in this section. So it needs to be completed on the input data. Then number 4, you're going to conduct your analysis, and you'll refer to the actual modeling cycle for the purpose, applicability, and the actual analysis that will be performed. There are reporting requirements. It tells you what kind of narrative you need to provide, the inputs and outputs that you need to report. And lastly, it requires that quality assurance be performed on the model output data as well. So someone should be looking at, do these energy usage indices for each end use, do they make sense based on the input data that was QA'd earlier in the process? So, it's a requirement that this happen. All right, next slide, please. Okay, some changes to this section. Again, this is a theme. Some changes were made to increase flexibility regarding requirements for conducting financial analysis and setting goals. Again, we just opened it up. You don't have to do a financial analysis, but informative notes were added to alert modelers that, hey, you might not have to do a financial analysis, but it's pretty beneficial for most projects. So there'll be informative notes about that throughout the standard. Number 3, the language was such that it was expanded to be inclusive of reporting on metrics beyond just cost, because previously the focus was cost. So now this section refers to greenhouse gas emissions, source energy. So it's expanded the different metrics that are reported upon as they're relevant to the project goals. All right, next slide, please. All right, now I'll pass it to Patrick Peace.
Thanks, Christina. I'm going to walk us through some of the modeling cycles and the refinements that have been made, and also some refinements that are coming up. First thing I want to highlight here, this diagram that we see, this summarizes all the cycles that are part of the standard. And these diagrams and several we'll see moving forward are actually now part of the standard in a report of an appendix, and really are meant to be used to help charrettes or design teams kind of communicate the process as they follow. We'll jump forward. So the first modeling cycle we have is called the simple box modeling cycle. Within this, essentially what we're doing is we're creating the simplest form of a model, and we're looking at a couple variables to determine the sensitivity of the overall performance, energy, peak loads, etc., to those variables. Kind of key here is that the timing. This is very much a concept design cycle, and it's meant to be done before, or if it's a very active charrette, it could be during the building performance charrette. If you go to the next slide, this is a cycle that we made quite a few refinements to. First, we added the indication that we should look at the sensitivity of these parameters, not just the parameters themselves, to determine, is this an important one to look at moving forward. Also clarified that this is applicable to use parameters that make sense for the project. For example, an existing building that can't rotate, we shouldn't look at rotating it because it's not going to be possible on that project. Finally, we include an informative note that geometry does not need to be a simple box. There's some history to the term simple box, but it's really about the simplicity of the model, not so much the form. So we've clarified that the model can be, showing a rectangular or the shapes that match, the project's needs. We go to the next cycle. Next cycle is concept design. Concept design cycle is meant to be done anytime before schematic design, and it's for when the form and the architecture is not yet fixed. So this is a cycle all about looking at what if we change the shape of the building, the rotation, the window, the wall, all those types of things we're exploring within this cycle. A key component here is that the primary practice is to keep HVAC constant, and that we're looking at changing the building form and the architecture. And we're seeing, again, our energy, our peak loads, how they interact with that. If we move forward, this one as well, we've made several refinements. One that I think is important is we clarified a deliverable here, is that the modeling is meant to assist with design decisions, kind of making that clear. The purpose of most of these cycles, and this one in particular, is to assist the design team with deciding between A and B, kind of as visualized here. Another important exception that was added is recognizing that some HVAC systems result in a change to the form or the architecture of the building. So if that's the case, those would be incorporated into this cycle. We go to the next cycle. Cycle number 3. This is perhaps the most important cycle within the standard, load reduction. It is the only one that's required for all projects to do in order to meet the requirements of the standard. And it's done in that way because load reduction is so important. Reducing our heating and cooling loads is critical to high performance. Passive design really is a huge benefit moving forward. And so in that fashion, it is required. It's meant to be done again before the end of schematic design. And it's also meant to be done before kind of final selection of the HVAC systems. Kind of let's reduce loads before we decide on the exact chiller, for example, that will be used. If we go to the next slide, this cycle has a few key refinements. The first, as the industry looks more towards electrification, we've added a consideration for peak electricity demand or other fuel sources demand as a thing to look at as far as reduction. We've also clarified an equipment threshold within this cycle to make it more user-friendly and match the rest of the standard. We go forward to cycle 4. Cycle 4 is the HVAC system selection cycle. And this one's all about, once we reduce the loads on the building, how do we decide on that HVAC system? Let's say VAV versus DOAS system. How do we compare those and come up with an outcome? The process for this standard, for this cycle, is to look at least 2 HVAC systems. And in this case, we're looking at annual energy. We're looking at, how can we recommend those HVAC systems based on that? I do want to highlight that this cycle and also cycle 4 coming up is going to be coming up for public review very soon. The committee's worked through some updates to these 2 cycles that will be on the ASHRAE website for public review, and we definitely encourage people to be part of that process and provide feedback through that medium. Cycle 5, this is our design refinement. Design refinement is meant to be done, again, after the load reduction. And in this case, we're looking at refining aspects that aren't specifically the HVAC selection, but it could be looking at, for example, the domestic or service hot water systems, the space programming, just other aspects of the building that we want to refine as we're moving forward into more detailed levels of design. The outcomes, very similar to the others, will be our energy reduction, hopefully, from those changes, demand reductions. And again, these are all utilized to reduce, or sorry, to drive decision making and assist the design team in that process. Finally, going on to cycle 6. This is the design integration and optimization overview. This is meant to be done before the end of construction. So we're kind of getting nearer and nearer the end of our design phases here. And this is one that's set up to allow us to compare really complex interactions. So really getting into the weeds of comparing at least 2 design variables, could be 2 systems, 2 envelopes, etc. And looking at that really multiple objective optimization. What is the CapEx? What is the OpEx? What is the energy? Really pulling that together, again, to assist with that idea of making key design decisions ahead of the project moving forward. I'm now going to pass it back, I think, to Christina for the next slides.
Sounds good. Thanks, Patrick. I'll take over at modeling cycle number 7. So the way I'm explaining this on this slide is consistent with the 2024 version of this modeling cycle. It's called the Responsive Design Alternative Modeling Cycle. And we all know when we're the modeler on a project and a member of the design team comes to you and says, hey, I can't get this window, but I can get this other window. The U value is much worse. How will it affect the model? And you're like, oh, we didn't really budget to do these iterations. Well, that's what this cycle is designed for. Responding to these requests for modeling and evaluating the performance impact of these proposed design changes. Commonly, this is done during construction documents, during the value engineering period, but these analyses can be done really at any point throughout the design process as proposed design changes come up. Next slide, please. And really, it was changed. This cycle was changed quite significantly from 2018 to 2024. The name was changed. This used to be Energy Simulation Aided Value Engineering. So it was focused completely on value engineering alternatives before. So it's no longer limited to that period. And first costs of each alternative are no longer required. However, design alternatives really should only be evaluated if they're likely to affect project performance, right? And informative notes were added to improve clarity and help improve analyses. For an example, it talks, this informative note you see here points out how important that first and operating cost differences are typically. And basically suggests lightly that they should be evaluated, but perhaps that's not necessary. Perhaps the design team says, this is all I can get. Will we still meet our goal? And you're just not even factoring cost in. You just need to see if you'll meet the goal. Okay, next slide, please. All right, so now I'm going to go on briefly touch on the construction and operation modeling cycles. Remember, we talked about how there are design, construction, and operation modeling cycles. Next slide, please. So the first in the construction document stage is the as design energy performance modeling cycle. This is simple. If you're modelers, you're probably extremely familiar with this cycle. It's sort of, we call the accounting modeling cycle, where you're given, the as designed design documents, and you create a model based on the as designed building. And of course, your goal is to make sure the project is meeting the performance goals established early in the design process. Next slide, please. The next is change orders. So during construction, we all know that change orders often come up. So this cycle involves updating the energy model to assess the impact of the proposed change orders. And you'll, as a model, will provide feedback on the impact, ensuring that the project still meets the performance goals, even with the change orders. Or maybe the project teams needs to explore a different option if the project no longer meets its goals with various change orders. Next slide, please. All right, so now we're into in operation cycles. This is as-built energy performance. So now the building is constructed and you are updating the energy model to include all of those change orders that occurred during construction to evaluate the performance goals. So it's a final true up to make sure, you met those performance goals established in the beginning. Next slide, please. And modeling cycle number 10, this is completed about at least 12 months after the building has been in operation. And you're basically comparing the modeled energy performance to the utility bills. You might need to use the actual weather file for the utility bill period in your model. Models typically use TMY data, so you can either use the actual weather data or conduct some kind of regression analysis to account for differences in weather across the TMY data and your actual utility period. But you're trying to assess to troubleshoot to see if there are any performance issues with the building. And so this can you can identify issues with maybe equipment failures, maybe there are different the occupancy schedules are different. So this can help inform future models. And you can also provide pass on feedback to the building operator if you notice any areas where that should be further investigated to see if maybe equipment isn't functioning properly or something like that. Next slide, please. Okay, so the name of this cycle was changed and it was simplified greatly. The changes were made to align the level of detail in this cycle so that it's more consistent with the other cycles. This was a 2-page modeling cycle previously, and the other modeling cycles maybe took up a quarter of a page. So a lot of the detail was removed. So an example is shown on the slide. It used to include equations for calculating modeling uncertainty, but all this information is actually contained in ASHRAE Guideline 14. So this detail was removed from the modeling cycle, and instead the cycle now points users to ASHRAE Guideline 14. And really this was just to make the cycle more user-friendly and accessible to modelers. Next slide, please. Okay, and this is a real easy one. So earlier in this webinar, I mentioned benchmarking information. So this is where you can, Appendix B, you can find benchmarking resources. And the major changes made from 2018 to 2024 is one, additional resources were added, and it was better organized, so it's easier to digest the content. So you can see the layout of 2018 on the left, and you can see it was organized into a nice table in the 2024 standard. So those were the major changes. Next slide. All right, now I'm going to pass it back to Patrick.
Perfect. I'm going to talk through quickly Appendix C, which is one we updated quite a bit in 2024. This is our modeling inputs for simple box, and a refinement that we made is it's also useful for other cycles. This is essentially a collection of information and references that can be used when inputs are not known. So if we know everything about the building but don't know the window to the wall, this appendix gives us a very good way to reference that. The 2024 version, we added quite a few references in here, and again, kind of expanded its use case to any cycle that you might need to fill in some blank information. Next slide. Here on the right is just an overview of how it's structured. As you can see, we have typical parameters that you'll need to have within your model and a reference of what to fill in, again, in that idea of if not known. I mentioned the window to wall example. Another one might be if you're doing a cycle 4 or even a cycle 3, and we don't know the schedules for the building just yet, the appendix provides you where to look for those schedules so you can assign them to the equipment, the lighting, etc. within your building. Next slide. A new informative appendix that was added in this version is Appendix G, Predictive Energy Modeling. This provides information on use and considerations for using predictive energy modeling. It includes quite a bit of content, including defining a goal around that predictive energy modeling, quite a bit of information about using and the considerations of doing so, and then looking at the renewable energy aspects of predictive energy modeling, storage, and demand response. Just quick note, all of these informative appendixes are not requirements within this standard or truly any ASHRAE standard, but are really useful guides shared within the context of the standard. Next slide. So predictive energy modeling, this is perhaps a new concept for some of us. So I wanted to provide a quick definition. It's essentially used to predict the actual energy performance of a building to meet a specific target outcome. By in comparison to what it's not. Predictive is not comparative energy modeling, which is essentially what code compliance modeling is. So if we look at the standard informative note from ASHRAE 9.1, clearly it finds out this should not be used to predict the energy. This is a different approach to that energy modeling that's more appropriate if that is in fact the end goal. So some of the outcomes there being net zero energy determination and others. Next slide. Just to think through visually, as I mentioned, one use case of this is determining if your building can achieve net zero energy. That could be various above code certifications that the project's going for, client goals, things like that. And so predictive energy modeling allows you to meet that target. It can also be used for net positive energy planning. For LBC, for example, where beyond net zero, we have to show positive generation, and predictive energy modeling is key there to have confidence you'll achieve that goal. And real quick as well, it does cover a sensitivity analysis. And this is really all about looking at, now that we've predicted something, how confident are we in that prediction? So it provides some framework and context to look at a way to gain that confidence and know what level of contingency or safety factor will you want to think about if you were actually going to guarantee or seek to guarantee net zero or net positive operation. So that's all included as well. And I think next slide, I can hand back over to Chris.
Yeah, I'm going to do my best Drew Crowley impersonation here and just talk very briefly about Appendix F, future climate analysis. I think one of the things we're all aware of is climate change and how the world is changing, and that affects the way we do energy simulation. And so in 209, we've created a new appendix that gives us some guidance about how we might approach this future climate analysis. So just real quickly running through this on the next slide. What we know is that weather and climate are different things. Climate is actually the generally prevailing conditions through the year averaged over a series of years. And that's what we're typically using when we're doing any kind of building simulation. We are interested in both the typical year so we can predict energy, but we also want to look at unique conditions so we can look at things like peak loads. So, just some of the illustrations here on the next couple slides showing how, in fact, the weather is getting warmer all the time. We're setting new records. And the next build of slides shows some of the temperature differences over the course of time going up and what that means in each year as we get a little bit warmer relative to these averages. So just click right through there. There you go. And so what this means is that we need to think about when we're modeling for. When we typically run a model, we are using something called a TMY, a typical meteorological year. So that's not an average year, it's a typical year. So it's meant to get the highs and lows of a typical year, but it reflects on average what the typical year would be over a given time period. And so we have a lot of sets of TMY data that's currently used on the next slide that are out there. And one of the things we see is that these are based on the past, right? So here in my practice in Massachusetts, we've discovered when we're modeling for TEDI, modeling for absolute rather than relative, we're finding that the weather file we pick matters a lot for the answer that we get. It's much easier to pass with a TMY-X than the TMY-2 because the weather is warmer and so we have less heating load. So if we're thinking about a building for the life of the building, we want to think about the future perhaps. So there are different ways that we can approach that. Next slide. And so just again, some illustrations of how things have changed over time. Here are heating degree days at a few different locations. We see generally less heating degree days, generally more cooling degree days. And what this also means that for energy on the next slide, the amount of heating and cooling use can change significantly based on the weather file that we select. So one of the things we need to think about is what is the scenario that we're going to look at in the future? There are different scenarios, and one of the things you would do is pick which scenario you think is appropriate for the future you're looking at, and picking a time frame that's related to the the systems that you've got. And then there are a few different ways that you can create these files on the next slide. So we can either do what they call dynamic downscaling, which is where we take the big climate models and try to shrink them down to a weather file. We can also just do statistical models and look for trends. And then the most common thing we're doing, that most people are doing, is time series adjustment or morphing, where they're taking the existing files and then assuming some future changes to those, as opposed to developing them from the big climate models. And then another very common scenario that may be appropriate is to just find a location that's going to be similar to where you're going to be. So you might just say, if I'm in climate zone 5, let's pick climate zone 4 as an example for the future weather and see what that's going to look like. So those are all different pathways, and these are outlined in more detail in this appendix. And I think we got one more slide on there, just a quick summary. So the important thing here that the appendix is telling us is to think about the climate data you're using and recognize that it is one of many assumptions about the project, just like all the other parameters that go into it, and it creates uncertainty. And so then figure out what is the appropriate thing to use. And that's basically the gist of what that standard looks at. And we can do that by modifying existing weather files or by creating them from the larger climate models. Either one of those could be appropriate. And at that point, I think I'm going to hand it over to Eric. Let me just say, as we're heading over to Eric, if you have questions, please put them in the Q&A. Some people are chatting to us. We're unable to respond to the chats unless you put them in the Q&A.
Thank you, Chris, for that excellent Drew Crawley impression. Yeah, so there's also, I'll cover quickly, 2 more new informative appendices. So the first one is Appendix H, which we've been seeing excerpts from all along. This acknowledges the fact that ASHRAE standards are not necessarily easily understood or digestible in their normal written form. So we've got some more visual flowchart type presentations of the standard here. Also in Appendix H is this kind of table-based format. So for each of the modeling cycles, it's arranged where you can quickly see the purpose, process, desired outcome, and applicability for each modeling cycle. So check that out, share that with your friends and family to help them understand what it is that you do. And then there's a new informative Appendix I, which deals with the level of detail for model inputs. And I think we all know that models can be developed with increasing level of detail, right, as the design progresses, as more information becomes available, and that the appropriate level of detail kind of depends on the purpose of the analysis and how much time we have to spend. So our goal here is that we're creating models that accurately represent the building systems of interest while also avoiding the unnecessary complexity in modeling time. And those of you who've been doing this for a long time, you probably have an intuition regarding which inputs are important to spend time on and which ones you can make some quick assumptions on. So this appendix is more for somebody who's kind of getting into the business and would be looking for that kind of guidance. It defines this framework of model elements like weather, geometry, and zoning. And then for each of those elements, the various attributes related to different building energy models. So for weather, for example, there's a weather data file, there's design day conditions and ground temperature. And if you go look at the standard itself, this table will also have some descriptions of some of the considerations related to determining each of those outputs, or those inputs rather. So this is the framework. And then for each of the modeling cycles, there is a section, there's a table. This is just the table for this is an example of that initial table. So the modeling elements and their attributes, says the element, for example, constructions, their attributes, thermal properties, thermal bridges, surface properties. These are the kind of things that we have to describe, right, for energy models. And then some description, well, what are the typical options for representing materials that we can choose from, and so on. And then for each modeling cycle, there's another table. This is just an example of simple box modeling cycle. So for weather, for example, at this stage, a TMY weather file may be appropriate. For zoning, simplified perimeter core thermal zoning pattern is generally appropriate. So this is trying to kind of gather some of the expertise of the committee and provide some guidance on appropriate level of effort. Hopefully that makes sense. So I encourage you to check out that appendix and all the other ones. As Chris noted at the beginning, I think there's a lot of information, interesting, new, informative information, hopefully worth the price of admission. So let's see, we've got a few more minutes here for questions. I see that there's been a few asked in the Q&A. Any one of our panelists want to
I can take a
highlight
quick
that?
one. Greg Collins just asked, number 10 as built, is it a prerequisite of number 11? Good question. No, it's not. For number 11, in that case, you would need to update the model to align with the as-built model.
And it's also important to note, as I think was pointed out earlier, that those construction and operation phase modeling cycles are not required for compliance with the standard, but they're defined there so that perhaps an authority having jurisdiction or a client might say, I want you to do that one.
Mm-hmm.
Yeah, and as I mentioned in the comment, we have been working with the folks at USGBC to get a LEED version 5 innovation credit for using 209 in 2024. So hopefully that will be something that is out there pretty soon.
Let's see. So, okay, so we've answered some of these. Slides will be available. The draft 2024 standard has been published. And if you keep track of, if you want to keep up to date on the proposed changes, those will go onto the ASHRAE website soon for public review. And then you could download the text of those proposed change sections too.
I'd like to answer the one about 90.1 requiring 209. We actually in 90.1 added a note in front of the Appendix G, I believe, to say, hey, go look at 209 for guidance on how to do modeling. But we would not expect that 90.1 would require you to follow any part of 209 currently.
Chris, do you want to do a quick announcement about the new LEED optional credit?
Yeah, I think I just did that.
Oh, okay.
We're all scrambling to get the questions, so we may have missed it, but we have to wait for the final word from USGBC. But my understanding is that as part of the LEED V5 rollout, which happened on Monday, if you missed it, that went live, there's going to be a bunch of ready to go innovation credits, and one will be using 209 2024.
And Eric, will this webinar be available to watch again?
Yes. So there's a ibpsa-usa YouTube channel, and this webinar will be up there shortly. So please check that out, along with all the other exciting and informative ibpsa-usa webinars from the past. Let's see. So there's another question from Richard on any good sources for process load assumptions.
Yes. Appendix C does include quite a few references for process loads, including kind of ASHRAE handbooks, as well as NREL resources. So quite a few references to look at from Appendix C.
Another reference to plug is BEM Encyclopedia. If you haven't checked that out, I think the goal is to also include references for things like plug load process load assumptions there too.
Right. Yeah, I second that. So it's bemcyclopedia.com
Oh.
is the website. They have both a wiki that provides energy modeling guidance, as well as a section on lookup tables for potential loads and schedules inputs. So I think we're about at time. I really appreciate the attendance of everybody. If you're more interested in ibpsa-usa in general, either the education committee or any other committees, then I really encourage you to go look at the website for ibpsa-usa, ibpsa.us, and you can find a section that lists all the committees and contact information for getting involved. Really encourage you to do that if that might be something of interest.
Yeah, and if you saw something today you don't like or you want to add to 209, we encourage you to apply to join the 209 committee as well.
All right, thank you, everybody, and thank you to Patrick, Christina, and Chris as well.
Thank you. It's a pleasure. Bye, everyone.
Thanks, everyone.